Alright guys, so we are going to be finding a list of potential zeros that will help us eventually to factor polynomials. Okay, so sometimes there are not any factoring techniques that we can use on a polynomial, at the start at least. And we also sometimes will not have a lovely graph to look at to get zeros off of. So when factoring fails us, as well as when we don't have a graph, we have to try to find another way to factor the polynomial and find zeros. Okay, so we have to be able to find some way to find the zeros without a calculator and without factoring. And we can through the rational zero theorem. And what the rational zero theorem does, you guys, it gives us a list of potential zeros. So the list I'm about to make here, these are not all the zeros, which I'll explain why in a moment, but it gives us a list of things that we can try using synthetic division. And remember, from when we had a graph to use when we would find the zeros, okay, remember, we're going to put these numbers in synthetic division, which then will help us to reduce down our equation, and hopefully, eventually we can factor, we can find the remaining factors, and then find the remaining zeros. So, let's get going. Alright guys, so we're going to do a test called the P, Q, and P over Q test. So the P, Q, P over Q. And the way this works, the way we get the values of P comes from the very last term of the polynomial, and we're going to write all the factors of that number. Now, when we write our factors, we're going to put a plus and a minus symbol with them because positive and negative numbers go into 48. Now, when I list out my numbers, me personally, I like to list them in numerical order, so from smallest to largest, okay, but you don't have to do that, okay? So, things that go into 48. Well, I know that 1 and 48 do, so I got my 1. I know that 2 and 24 do, so I'm going to put 2. Okay, I know 3 will go into it. 3 times, let's see, 16. So I got 1, 2, and 3. And you see, guys, I'm listing the positives and the negatives at the same time. All right, 4 will go into it, definitely. 4 times 12. All right, 5 won't go into it. 6 will go into it. Those 6 times 8. So 6. 7 won't go into it, but 8 will. And if you see, you guys, now I'm kind of backtracking because 6 times 8 gives me 48. So now I'm not coming up with new things to multiply to go into 48. So now I can kind of backtrack and say, well, 6 times what gives me 48? 8. 4 times what gives me 48? 12. 3 times 16 gives me 48. 2 times 24 gives me 48, and 1 times 48 gives me 48. Alright, now if listing them out in this way is too confusing, they don't have to go in order. You could have wrote like 1 and 48 side by side, since 1 times 48 gives you 48. You could have written the 2 and the 24 side by side, since 2 times 24 gives you 48. Me personally, sometimes I'm a little OCD, I'm not going to lie, you guys, and I like things to be a certain way. And me personally, I like them to go in order, but you don't have to put them in order. Alright, so our P's are done. Yes. Alright, guys, now where the Q's come from, the Q's are going to be all the factors of the coefficient of the first term. So the coefficient of the first term, the number in front of the x to the fourth, is a 2. So I'm going to write everything that goes into right here. So 1 will go into 2, and 2 will go into 2. Holy hot dog, you guys. So now, this list right here, the P over the Q list, that is the most important part because that will be giving us our list of possible zeros that we're going to be using while we do synthetic division. Okay, so what we're going to do, we're going to take all the P's and divide them by all the Q's. Okay, and if any of the numbers repeat after we divide, we don't have to list them more than once. Okay, so I'm going to start by dividing all my numbers by the 1. So actually what I'm going to do, you guys, I'm going to start with my 1 and divide it by both. Go to my 2, divide by both. Go to my 3, divide by both. Okay? So 1 divided by 1 is 1, so plus or minus 1. And 1 divided by 2 gives me 1/2, so plus or minus 1/2. So my 1 is done. Alright, now I'm going to my 2 and divide by both. So 2 divided by 1 is 2. And 2 divided by 2 is 1, but I already have 1 listed, so I don't need to list it again. So that one's done. Okay, I go on to 3 divided by each. 3 divided by 1 is 3. Yay! And 3 divided by 2 is 3 halves. So 3 is donezo. Go on to 4 divided by both. 4 divided by 1 is 4. And 4 divided by 2 is 2, but I already have a 2, so I don't have to write it again. So 4 is donezo. 6 divided by 1 is 6. Alright, and 6 divided by 2 is 3, but I already have it, so I don't have to list it. Yeah. Alright, go on to 8. 8 divided by 1 is 8. And 8 divided by 2 gives me 4, but I already have it, so I don't have to write it. Moving on to 12. 12 divided by 1 is 12. And 12 divided by 2 is 6, but I already have it, so I don't have to write it. Alright, 16 divided by 1 is 16. I'm going to keep writing them down here. 16, let's see here. Yeah, 16 divided by 2 is 8, but I already have it. Bam. 24 divided by 1 is 24. 24 divided by 2 is 12, but I already have it. So bam, donezo. And last one. 48 divided by 1 is 48. Holy hot dog, right? And 48 divided by 2 is 24, but I already have it, so I don't have to write it. So what we have here, you guys, is a list of potential zeros that we're going to be using while we complete synthetic division. So if you think back to the example that we just did with the graph, these are basically possible zeros that might be on the graph, and we're going to be testing them in synthetic. And remember, if the remainder is 0, it means that these are going to be 0. So that's going to help us to eliminate some of these down. Alright, so this is it. All we're doing in this one is listing out potential zeros. So this is my list of potential zeros. Nice. Alright, guys, now example 11 is pretty much the same as example 10. So, if you think you understand how to do example 10, go ahead and pause the video and fast forward to the end and see if you get the right answer. Alright, guys, let's tackle example 11. Alright, we got the P's, Q's, and P over Q's. So remember, the P is the last term in the polynomial. I'm going to list everything that goes into 30. So like 1 and 30 will go in there. 2 and 15. 3 and 10. 4 will not go into 30. 5 will though. 5 and 6. Alright, 6 will go, and now I'm starting to backtrack because 5 times 6 gives me 30. Alright, 3 times 10 will give me 30. 2 times 15 will give me 30. And 1 times 30 will give me 30. So I got all my P's. Yeah. Alright, now my Q's. I list everything that goes into my first coefficient that I see. Bam, right there. But holy hot dog, you're probably flipping out on me right now because nothing is in front of the x to the third. Well, guess what, you guys? There's secretly a 1, so you don't need to worry anymore. Alright, so I need to list everything that goes into 1. Well, guess what? The only thing that goes into 1 is 1. So my Q is plus or minus 1. Alright, and then to get the P over Q's, you take all the P's and divide them by my Q, which I only have one thing to divide them by, and I'm dividing them all by 1. So if I divide all these numbers by 1, anything divided by 1 is going to be itself. So basically, you guys, the P over Q is going to end up just being the list of my P's. Okay, because 1 divided by 1 is 1, 2 divided by 2 is 2, 3 divided by 1 is 3, 5 divided by 1 is 5. So if you see, we're getting the list of P values when we do this. So I'm just going to write all my P's. So this one wasn't as bad. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. Holy hot dog, you guys. Those are the list of potential zeros that we will have for this polynomial. Incredible.